Okay.
Just a minute. Good afternoon, everyone. On behalf of agricultureinformation.com, I welcome Mr. Rahul Arepaka and he will speak on the topic laser weeding technology. I now request the speaker to begin. Thank you.
Yeah. Yeah. So hi everyone. So I'm Rahul from Harvested. So we are a company based out of Hyderabad. We are trying to build, de-weeding technology for existing farm tractors. Uh, Yeah, so the issue of, weeding is it's huge, right? So we know hundreds of farmers, finding farming really difficult just because of weeding alone. And last year, uh, India faced a loss of close to $11 billion, due to weeds is what's being faced every year by the farmers. And you can also see some of the clippings of farmers reaching out to us on the weeding problem. Uh, the main problem of, the entire crop losses is weeds. And if you don't do weeding properly, you can increase the diseases and the pests on your farms, becomes difficult to harvest, and also, resulting in a very low crop yield. Now, there are farmers mainly using two major ways of doing weeding. Number one, you're doing manual labor of weeding, which is expensive and time consuming. So farmers are spending close to, 8,000 to 10,000 rupees per acre for doing one time of weeding using manual labor, which is very tedious and time consuming. Or the other method is by spraying chemicals, which is more of a blanket spraying process, which is harmful, and there's also an overdosage per plant. And if you do too much of chemical spraying as well, it sweeps into your groundwater. And this is repeated close to 3 times, 2 to 3 times per season. And farmers are spending anywhere between 6,000 rupees to 7,000 rupees per acre today on this method of elimination. And so what's our solution? So our solution is that we have an implement that goes behind tractors. So we have cameras that can analyze your farm, and we perform high power laser weeding on top of it, post the weed detection. So we are trying to build a model that's able to detect weeds and crops, and also the weed, what's the stem points, the germination points of these weeds detected, and we shoot the laser there, and we're able to burn weeds using lasers under zero point 0.5 seconds. So we have built like a robotic guided actuating system that goes behind the tractor that does the weeding process, and all this thing happens in real time, so you don't have to stop the tractor, so it goes in one motion. So our product is called Rakshak. So what we do with Rakshak is, as I mentioned, it's an AI powered weed detection software, and then we use lasers to eliminate them. As of today, we are able to do very high detection rate, and also we are having a close to, more than, 160, 200 watts of laser power. It's much more than that, in fact. And we have a high targeting accuracy of less than 3 to 5 mm. And the entire machine is a 3-point linkage, so it can attach to any existing tractor, and it also can be, it's also PTO powered from the tractor. So we are also working with even lesser HP of tractors, but at the moment we are working with testing it with 30 to 40 HP tractors. And so it's a plug and play machine. So the learning curve for any farm equipment is relatively less, because it just works like a normal tractor attachment. So this is the difference between the treatment before and after. So, so this is an image that we have taken of a crop of a weed that's been growing, and we have, targeted the laser on the stem point. So this is the result after, immediately after burning for, less than a second. And on the right hand side, you can see an image where we have continuously watered the same plant for close to 28 days, and we can see that the plant has not grown back again. So this is we were able to do it because we targeted at the at the stem point, and we were able to control the growth of that plant. So weeding is super important, and our value proposition with lasers is that number one, it's low, zero chemical spraying. We don't do any spraying process. We are not also disturbing the soil, so there's no churning of the soil happening, or we're not tilling any of the soil. And so we are trying to maintain less contact with the soil. And also we are trying to reduce the weeding cycles on the farms, because we are trying to make sure the weeds don't grow back on the same spot again. So we have done some testing, in terms of savings with the farmers. Is that, from using the laser weeder, is what we have done the calculation, is that for a 1 acre farm, and if you have a groundnut crop and if your weed density is medium, using spraying, you are doing close to 3 times, and you're spending close to, 20,000 rupees, close to 18 to 20,000 rupees of, cost for chemicals. And if you're doing manual weeding, you're spending close to 30 to 40,000 rupees for doing the weeding across 4 weeding cycles. But using our technology, we're trying to get that weeding cycle down to 2 to 3 weeding cycles. And also the time duration takes roughly 2.5 to 3 hours per acre. And and you just need to hire one person to drive the tractor, and you're spending, using our platform, close to, 10,000 rupees for the total, 10,000 to 12,000 rupees for the total, process of weeding. So that's close to 70% offering, farmers are saving per acre. So the machine, is, being sold. We're not for sale yet. We're still doing a bunch of R&D and collecting a lot of data. But we plan on selling our machines between the 10 to 12 lakh rupee price point, and with the maintenance, where we can continue to change the spare parts and make sure the cameras are all up to date, making sure all the lenses are fine. So we would have like a maintenance for our machines. So, what we're trying to do is we're trying to build the biggest crop data bank. So all our machines collect data all the time, and the data comes back to us. And we are so far collecting, we have collected so far 300,000 images on our farm where we are doing our testing. And we're actually testing using a cauliflower crop at the moment. And we plan on collecting, more and more data to make the model much more smarter and much more faster. And our plan is, in the future, if we get a chance, that we could also use our existing machines to provide analytics to the farmers, like number of crops, number of weeds, when we could expect the weed to grow back, and also if there's any diseases detected, because we also have near infrared cameras on our machines that collect the data for us. Right. So, we are actually working with, trying to work with. So, most of the farmers who are reaching out to us are farmers who already own a tractor. And also, most of the farmers who are reaching out to us in that segment are also farmers who are owning more than 5 to 6 acres of land holdings. So, we are planning on working with farmers who are owning more than 5 acres of land. And for the farmers owning less than 5 acres of land, these machines would be typically rented out to them, maybe through our dealerships or maybe through our existing fleet of network of farmers. Whenever the machine is not in use, because the machine is plug and play, it can work with any tractor. Right. So globally, in the weeding space, there are a lot of companies, and in the laser weeding space, total maybe there are close to 15 to 20 companies, including us, globally building this technology. And we are the only ones here in India at the moment doing laser weeding behind a tractor, and at the stage what we are in. And yeah, so, comparing our machines with global competitors, right? So we are based out of a diode-based technology, which means we are much more energy efficient. And other competitors like Carbon, Nescad, and Wheatbot, they're using carbon-based technology or fiber-based technology. And our acres per day is relatively less, because the machines are much smaller and built for the Indian farms, and we can cover less acreage, of course. So our machines, in terms of coverage width, is close to 6 feet, as compared to our competitors, which go around 20 feet in size. And our minimum tractor requirement is much lesser, so we can work with as low as even 20 HP tractors, or even 30 HP tractors, or even much less than that. And uh, and as compared to our competitors, you require at least a 100 HP tractor to work with. And our competitors sell their machines for close to 8 crores to 10 crores machine, with an annual maintenance of close to upward of 50 lakh rupees yearly. And where our machines we plan on selling around the 10 to 12 lakh rupee price point. A lot of farmers actually reach out to us on building this tech, for the technology. So we are trying to work and we're trying to get the machine as soon as possible out there. Right. Yeah. So, and yeah, and also I would love to show you a couple of videos, if you just give me a second, on how we, collect data from our farms.
Stop sharing the screen, is it?
Yeah, one second. I'm just
Yeah,
opening up the video one.
yeah.
So yeah, uh, this is, if you can look at on our website also. So this is our newest unit that we have built, right? Which we are collecting data on our 1 acre plot every day. This is a cauliflower crop, and I can just show you a more, detailed video on how we do the scanning process. Yeah. So this is the first version that we tested in Kolar in Karnataka. This is also this is a cauliflower farm as well, and where we've been collecting data using our machine. So we collect data in three different ways. I mean, in three main data points we collect. One is an RGB camera, one is an NIR camera, and also we collect with the GPS coordinate from which farm we're collecting. Because what we have noticed is that weeds vary from farm to farm. Yeah. So yeah, if anybody has any questions, love to answer it. Hello.
Yeah. Sir, your video, you wanted to share some more video, or I'll take up the questions?
Yeah, we can go ahead with the questions. If anything pops up, I'll love to show more videos.
Please share it, sir. Please share it. You have time.
Okay.
Later, I will take up questions. Okay.
Yeah, sure.
The video, we will not get audio, sir. You just explain what it is once the video is playing.
Sure.
Okay.
Oh, sure, sure. Just give me 1 second. I'll just show more videos. Yeah. Yeah. So this is one more video that have we just give me a second. I'm just trying to share the screen. Yeah. Yeah. So, this is one more version of a machine that we've been testing. So this is one of our initial prototypes that we have been working on. So in this version, right? So this machine is going on the creeper gear of the tractor, and you cannot really see the laser because it's a near infrared laser, so it's not visible to the naked eye. But I can show you how the burning happens with our other laser that we have been doing testings with. So we added a filter so you guys can see how well it can do the precise targeting, and it can burn the plant. So we have burned it for a much larger time, so you can see how we burn the weed. And I can show you which we have done testing with bunch of other types of lasers as well. So this is a 450, this is a close to a blue laser wavelength, blue violet laser. So this is a much lower watt laser, which we have been doing initial testings with. These are only 10 watts to 20 watts of lasers, but it took us much more, longer burn time to do the weeding of these kind of plants. I'll also, show you one more video that we have been testing with. Just 1 second. Yeah, so this is one more, this is our actually our newest lasers that we are testing with right now. So if you can see this, the weeding over here. So this is less than 0.5 seconds per weed what we're doing. So this is also a very low watt lasers that we are using. It's less than 200 watts. But right now we are working with, almost 4x the powers at the moment. So we can burn these kind of weeds in less than 0.5 seconds. Yeah. And also, by the way, this is one of the difference that we have noticed. So this is the difference between weeding and no weeding. So over here we have grown two cauliflowers on the same crop, same farm, same seed, same watering, same. But this plant over here, this crop over here of cauliflower, we have not done weeding at all. And this one over here, we have done weeding. We have done performed weeding, and we can see the yield of the crop is much better. Yeah. So yeah, I'm I'm done. You can I can take up the questions.
Yeah. Thank you very much, sir, for an wonderful and informative presentation. I will take up the questions now.
Okay.
The first question is, how does the system identify weeds and distinguish them from crop plants in real time?
Okay. So what we're doing right now is we're collecting the data at the moment. So once we collect the data, we have annotators which annotate them under the supervision along with an agronomist. And we build a model to, the AI model to detect what's a weed and what's not a weed. And this is everything happens through a camera system and an onboard computer. So in order to build this, we are collecting the data.
Okay. Uh, how accurate is the technology in eliminating weeds without damaging crops?
So at the moment, we have never, damaged any crop yet. And, we are all close to, and how we can burn, let's say there's a weed and there's a crop, we can burn, as long as the camera detects, we can burn as close as 5 to the main crop. We can do that much precise weeding. And it's only as in when we collect more data, we can do much more accurate detections. Yeah, obviously we have a layer between burning and the detection, that only if we get more than a certain percentage of accuracy, then after that only we will do the burning of the weed.
Okay. What role do artificial intelligence and machine vision play in effectiveness of laser reading?
Yeah, so this is the first step. So it's a see and shoot process. So if you don't do the detection well properly of the weed, so it's the main machine vision application over here is to do the weed detection and the crop detection along with the stem detections properly. So if this thing doesn't work, we cannot do the weeding process.
Okay. How can laser weeding help farmers reduce their dependency on herbicides?
Understood. Yeah, I mean, so the herbicides used in the weeding process, we're trying to replace that entire, process, right? So instead of farmers using chemicals or hiring people, we only use, lasers to do the weed detection process. There are a lot of research papers also telling that laser weeding is also effective process, and it's in fact a lot of, farmers are also globally are also trying to move towards laser-based weeding. It's a type of weed management. It comes under the section of thermal weed management, but we are much targeted.
Okay. How does laser weeding contribute to sustainable and organic farming practices?
Understood. So in our process, we use zero chemicals. We are trying to, in fact, we make the yield. We are, using because of weeding, we get a much better yield of the crop. And also, we are not using any chemicals in this process. So you can consider it to be organic weeding, organic, farming practice.
Okay. Can this technology help address the growing shortage and cost of agricultural labor?
Yeah, so even in our farm, right? So it becomes extremely difficult to find labor to do the weeding process. So in order for our machines to work, you just need a person who can drive a tractor.
Okay. What are the economic benefit of laser weeding for small and medium scale farmers?
So if you're looking at a rental mode, right? So if you want to rent out a machine and do the entire process of weeding, it'll cost per acre roughly 5,000 to 6,000 rupees as compared to 10,000 rupees of manual weeding. And so it's in that way, it's almost 50% more savings to the farmers.
Okay. Which crops and farming systems are best suited for laser weeding technology?
Any row crops, we can work with a majority of row crops. Wherever there is crops growing in rows, we can work in those kind of crops.
Okay. What are the operational costs compared to manual weeding and chemical weed control?
Operational, so I mean, obviously, number one, you need to look for a driver for your tractor, and the other one thing is a diesel cost, and also we run at a very low PTO speed, so your consumption is also very less, and you can also run our machines at the economical mode of the PTO shaft, so we consume much more less diesel, and I mean, at the same diesel, we're getting much more higher RPM. And yeah, so the mainly two things, these three things, and if you don't have a tractor, you have to rent out a tractor. So these are the three main things: diesel, tractor, and a person to drive it. That's the only operational things that you look at.
Okay. What level of training is required for farmers to operate and maintain these systems?
I mean, obviously, there's a little bit of learning curve, but yeah, so we designed the machine in a such a way that any farmers can operate, and we are also, in fact, working with a couple of farmers while designing the machines. So, just like a rotavator, you attach the PTO shaft, attach the 3-point linkage to your tractor, and you just go to the required RPM, on the machine as compared to your tractor. And yeah, the machine is very farmer friendly as well. So there's a start button. You just have to click that button and you're good to go.
Okay. Can this technology play a role in combating herbicide resistant weeds?
Yeah, I mean, we can wherever we as long as we detect a weed, we can burn it properly, regardless of whether it is chemical resistant or not.
Okay. So how adaptable is the technology to Indian field conditions, including uneven terrain and mixed cropping systems?
Yeah, so in mixed cropping, we can work in uneven terrain. There's no problem with it because a machine is already rugged, and we are trying to do waterproof, weatherproof, and all that. And in terms of multiple crops, so we have an option where we will put a feature in the machine where farmers can select what all crops they're growing, and we can detect those crops and eliminate the weeds.
Okay. What inspired Harvester Robotics to focus on laser weeding solutions?
Yeah, I mean, we were working with a bunch of other companies and implementing their technology to laser-based elimination. And, we have also seen a lot of research happening around laser weeding and how it could be one of the most effective ways of doing weeding. And we were talking to a lot of farmers here in India while building this. So we decided that why don't we do this for India and for the Indian farm? So that's when we started this.
Okay. What are the biggest challenges in scaling laser weeding technology across India?
The majority of the biggest challenge would be data collection, making the database. So that would be a biggest, you know, you know, blocker for us. So we are trying to work with we want to work across farms in India, collect as much as data and make it, better.
Okay. Are there any government schemes or subsidies that could support the adoption of such technologies?
Uh, Sorry, I did not get the question.
Are there any government schemes or subsidies that could support the adoption of such technologies?
At the moment, we haven't explored that option yet, but we are trying to work on towards that. At the moment, I don't think so.
Okay. Do you believe laser weeding can eventually replace herbicides entirely, or will it remain a complementary technology?
That is something that we really have to dig more into and see how it, with working with a bunch of, if so, we are trying to build a machine to work across majority of the crops. So once that's there, I don't have a, right answer at the moment, but yeah, we are trying to reduce the herbicides wherever possible.
Okay. What advice would you give to young entrepreneurs interested in building robotics and AI solutions for agriculture?
I think a lot of more companies have to come into the agriculture space so that a lot of farmers have more options to choose from, and also it helps to educate a larger, larger set of farmers, so they know about such technology. So I think a lot of companies and a lot of people need to start this in this space.
Okay. What are the biggest challenges in scaling laser weeding technologies across India?
Yeah, so as I mentioned, the biggest challenge would be to collect the data. So if your data is not there, you cannot do weeding properly. So in order to make your weed detection model, you need to collect as much as data across crops.
Okay.
Yeah, yeah.
Yeah, yeah. Just a minute, sir. Okay. I have now completed the round of questions from our side.
Mm.
On behalf of agricultureinformation.com, we would like to thank Mr. Rahul for the talk and for answering the questions. This meeting will now be closed.
Okay, thank you.
Yeah, most welcome.